Let us see the solution to this question number 2. If the initial population of pandas was 100 and grew to 125 after the first year, which of the following functions best models the population of pandas P with respect to the number of years T if the population growth of pandas is considered to be linear? Let us remember first that when we talk about exponential and linear growth, two different curves can be noticed as patterns for the corresponding increase of the variable. Comparing exponential and linear growth can be appreciated in these two graphs. Okay, on both planes of coordinates, we are mapping the time or the number of years passed after the initial moment, that is on the horizontal axis T, and the size of the population in the vertical axis. What is the exponential growth curve like? Well, it is something like this. At first, we appreciate a slow growth pattern, but then it suddenly goes up really quickly. That's the exponential growth pattern, which implies that the rate of growth is a fixed percent every period of time. On the contrary, the pattern for the linear growth is like this. As you can see, every period of time that passes contributes to a fixed increase in the variable P. So let's say that here, this value on the vertical axis, which actually represents the intersection of the curve with the vertical axis, here the same, let's call these values A. Those are the initial size of the variable we are measuring over time, that is in this case the population. It represents the population at time 0, okay? Because we consider that here the origin of coordinates is 0. So at that initial moment, A represents the initial size of the population. What about the description of this curve as a function? We can express that B equals A multiplied by a growth factor, which is 1 plus a percent we can call X. This is a fixed percent each period of time, and this factor needs to be raised to the power of T, where T represents the number of years passed. While for the linear growth pattern, what we have is that the size of the population after T periods of time is the size of the population at the beginning, that is at time 0, plus a fixed increase every unit of time that passes. On one hand, in the exponential growth pattern, X represents a fixed percent, while in the linear growth pattern, X represents a fixed quota by which the population is increased every period of time. So, since the question says that the growth of the population of pandas is considered to be linear, then we need to adopt this pattern. So this pattern has a curve that can be described using this pattern. Let's take a look at which of the answer choices matches more closely this pattern for the linear growth. Okay, we can see that both B and C match an exponential growth pattern, so we can discard these two on the spot. While option D actually matches a different pattern that we haven't even discussed in the course. Here we see a quadratic exponent, so we discard this on the spot. We're looking for the pattern of a linear equation, which is actually the first one. Notice we can confirm that the initial size of the population, that is, the value that results of substituting T for 0, if you substitute T for 0, P equals 25 times 0 plus 100, so the value of the initial size of the population would be actually 100, as the statement confirms. And after growing for the first year to 125, this can be also confirmed with this curve, with this function. If we substitute t for 1, then we have p equals 25 times 1 plus 100, which would be actually 125 pandas. So we confirm this is a good model, and so the correct answer choice is option A.